All right, next topic is going to be selective precipitation. And so let's say in solution, we have an aqueous solution, and inside the solution is some magnesium 2+ and some calcium 2+. And so let's say that we want the magnesium 2+ to precipitate out so that we can separate the two solutions, right? If we can get one to precipitate out without the other precipitating out, then we can separate the two. And oftentimes in chemistry, we want to separate things. We want to purify things. And so what we need to do is find something that will precipitate out one cation, but not the other. And so what you might do here is look at a table of KSPs and try to find something where their KSPs are significantly different that you can precipitate out one without precipitating out the other. So for example, let's say on this table, you found some magnesium hydroxide and you found that this KSP was 2.06 times 10 to the negative 13, while the calcium's hydroxide's KSP is equal to 4.86 times 10 to the negative 6. So the first thing that we notice is that our stoichiometry is the same. So we don't have to convert to the molar solubility. We can just compare these values right away. And so we see that the solubility of magnesium hydroxide is significantly lower than that of the calcium. Right, it's much smaller. And so what we can do is we can slowly add some hydroxide. And what's going to precipitate out first? Well, it's the first Q that's going to hit the K. And since the magnesium hydroxide K is much smaller, we should get out some magnesium hydroxide first. Right, so for example, if we added some sodium hydroxide to this, we end up with a solid of magnesium hydroxide. And then in our solution remains the calcium 2+. So you can see we've separated out the two solutions. So let's take a look at let's say that for the next video.